everyone, I am Ms. Hu, your physics teacher. In this video, we are going to go through one of the questions in this past year paper. This paper is paper 4 theory of the October-November 2023 variant 1. We will be going through question 2, which is a question from the thermal physics unit. Now you can see this question requires a lot of written words and there are no calculations in this question. So instead of me just telling you, oh, this is what you should write in your answers, let's check against the mark scheme, because the best way to make sure that you have written what you need to in order to get marks is to check what is really in the mark scheme. There are a lot of students who think that they know the topic well, but because they can't write the answers out, they can't get full marks. So let's check the mark scheme. So I've placed a mark scheme at the bottom here so that we can check the answers directly against the questions. Question 2. A copper cooking pan contains water. Figure 2.1 shows the pan on a hot plate of a cooker. Now, actually, if you look at the diagram, whatever's in the diagram is rather irrelevant. It's not really going to help you with the answer, but at least visually, it gives you an idea of what's going on. Copper is a metal. A. Thermal energy is conducted through all solids by lattice vibrations. Describe one other way in which thermal energy is conducted through the copper. Now, this is a 3-mark question. That means your answer should have at least 3 key concepts. First of all, let's examine what the question wants. If you read the question carefully, you can see that this is a question about thermal conduction. The word conducted comes out twice in the question. This is a description question, which means you just need to describe what is going on. You don't actually have to explain. So in this case, it's more of a process about how thermal energy is conducted. But here's the thing. The first sentence already gives us the description about how thermal energy is generally conducted, which is what you have learned, right? When thermal energy is conducted through solids, it's through the vibration of particles. We know that solid particles are all really close to one another. So when one particle vibrates, the thermal energy is conducted through vibration. If it's already mentioned here in the question, don't talk about it. The question already says, describe one other way. So you got to think, what is the other way in which thermal energy can be conducted? So if you can recall, when it comes to metals, there is another way in which thermal energy can be conducted. And they've already mentioned here that copper is a metal. So talk about the other way in which thermal energy can be conducted through metals. And it's all about the free moving electrons. So that's why if you refer to the mark scheme, 1 mark is awarded for the mention of these free moving electrons. As long as you use a term that is the same as free moving electrons, they will accept it. So you can say free, delocalized, or mobile electrons. So as long as you mention the availability of these free moving electrons, you will get 1 mark. So because thermal energy conduction is a process, how you get the other marks is to describe the process from start to finish. That means talk about, first of all, how the electrons gain energy and how they're able to conduct this thermal energy throughout this metal. So if you look at the mark scheme, after the mention of the electrons, 1 mark is awarded for the mention of how these electrons gain thermal energy. So they gain thermal energy either from the hot plate or from other particles. What happens next? Now we know these electrons are free to move, so talk about the movement. So you can either mention that they move throughout the copper or metal, or that they move to distant particles. 1 mark is awarded for either one of these mentions. That means as long as you mention that they move. 1 more mark can be awarded for the mention of how this energy is transferred. So the electrons can transfer energy from higher temperature to lower temperature, which is based on the concept of temperature gradient. If you can recall, thermal energy is always transferred from higher to lower temperatures. So the mention of this can get you 1 mark. Or you can mention that these electrons collide with other particles, or that they transfer energy to the distant particles. So again, if you review the mark scheme, 1 mark for the mention of the free moving electrons, another mark for how they gain the energy, 1 more mark for how they move, and 1 mark for how they transfer. So that's how you write the answer out. Because this is a description question, you describe the process. What are the particles that actually move? the electrons, where they gain the energy from, what happens, which means they move, and how they transfer energy. In this case, the mark scheme is quite lenient. You only need to write 3 out of the 4 available points to get full marks, and they even allow alternative options to what is written. So remember, this is a process. Describe the process. Now let's move on to B. The outside surface of the cooking pan is kept clean by regular polishing. Explain one other advantage of keeping the surface of the pan shiny. Now, in case you're wondering, oh gosh, what is this about and how do I even get started? Remember that this is a thermal energy question. How do we know this for sure? The hint is already given to us in A, because A is about thermal conduction. So this is something to do with thermal energy and most likely about thermal energy transfer. A has already talked about conduction. Let's consider the other methods of thermal energy transfer. There are 2 more, right? Convection and radiation. So if you look at B, this has nothing to do with convection because thermal convection involves only fluids. That means liquids and gases. This is about the cooking pan, so not about convection. Now let's consider radiation. Do shiny surfaces have anything to do with radiation? Yes, they do. Shiny surfaces are very good reflectors of thermal energy, and they're also very poor absorbers and emitters of thermal energy. This question asks us to explain. That means you need to explain the concept of this thermal radiation in terms of the shiny surface. So let's look at the mark scheme. 1 mark is awarded for the mention of shiny surfaces being poor emitters of radiation. You can see in the mark scheme, it does not mention anything about being a poor absorber or a good reflector. So if you wrote that down, you're not going to get marks. And why is this so? Remember that just because something is true does not mean that's what the mark scheme wants. Because you need to write facts that are related to the question, not just because, hey, this is true, let's just write this down. You got to think of it as what is the relationship with the fact that you know with this situation. So in this case, this cooking pan contains water and it's about how we can keep the hot water hot. There is no point talking about the shiny surface being a good reflector. The question mentions the outside surface. So don't talk about how the inside is able to reflect heat back to the water because that's not answering the question at all. And on the outside, what has it got to do with keeping the hot water hot? So even if it can reflect the heat on the outside, that has nothing to do with keeping the hot water inside hot, right? Because if it reflects the heat, okay, so what? The hot water is inside the pan. And if you want to keep the hot water inside the pan hot, it is about reducing the energy loss from the hot water to the surroundings. So although yes, the shiny surface is a poor absorber of heat, but in terms of reducing the energy loss to the surrounding, it is more about the poor emission of heat because the shiny surface cannot take the heat and lose it to the surrounding. So that's why marks are awarded for the shiny surface being a poor emitter of radiation. And then another mark is awarded for further explanation, which is that it reduces the energy loss or that there's less energy transferred to surrounding. So you can see in the mark scheme, there are 2 options because both are somewhat similar. So only 1 mark will be awarded for the explanation. And that's how you can get the full 2 marks. Now for C, the thermal energy passes into the water through the base of the pan. Identify the main method by which thermal energy is transferred throughout the water. And again, you can see this is a thermal energy transfer question. So if you look at A, this was thermal conduction, B is about radiation, C is 1 more thermal energy transfer, and then you're talking about water. So if you can recall what you've learned, and also I've just mentioned this, there's 1 more method of thermal energy transfer, which involves liquids and gases. Since water is a liquid, this is obviously convection. So you'll find that there are many questions in the exam paper where they're all related around the same topic within that unit. So this entire question, as you can see, is about thermal energy transfer. So this is how you solve question 2, which is a question from the thermal physics unit. Do check out my channel for videos on other questions from past year papers.